Okay, so today we're going to look at part one here of the review guide for our benchmark exam that's coming up. And so if you need to pause the video or anything, you can, or ask a question for those of you that are here. And we'll work fairly quickly and try to get this thing knocked out, okay? If you choose to work at your own pace, then that's fine. Just know that we'll won't be going backwards or jumping around. So either way, we can come back at the end if you need a little extra time. So starting off with going back to climate change, one of the first things we defined was the atmosphere. Okay, and the atmosphere is simply a thin layer of gases. Excuse me, move that lamp a little bit. So that's just a thin layer of gases that surround the Earth. Okay, and it is about 78% nitrogen and about 21% oxygen and 1% other. Okay. The greenhouse effect is simply a trapping of heat due to the gases, different types of gases, the trapping of heat due to different types of gases. The ice age is a time of ice covering the earth. And the reason we have that definition in there is to say to you, were there other times that that global warming or climate change occurred? And the answer to that question is yes, there were other times where that occurred. And one of the examples of that other time is during the ice age, okay? All right, let's see if I can find maybe a different pen that shows up a little better. So it's just a time of ice covering the earth. And again, these are note-taking type vocabulary. You can go out and look up the fuller definition if you want to. Go back and look in your notes, okay? A proxy is an indirect measurement. Hopefully you can see this a little better. An indirect measurement, and we use ice core to make those measurements. So the indirect measurement tool we're using is an ice core. Of course, sunspots is a spot of greater radiation on the sun. And we want to know that again because are there other factors that affect climate change besides those that are human controlled? And yes, sunspots is one of them. Thermal expansion is an increase in the size of an object due to heat. Okay, lots of things thermal expand, but water has a little bit of expansion as it changes heat, changes temperature. Coral bleaching is an effect of, let's put this, it's an effect of acid or acidic ocean due to climate change. So coral bleaching is one of the effects, one of the things we want to think about as climate changing is occurring, okay? Albedo, that's the amount of reflective. The amount of reflective light or how much it reflects. Again, that's probably not the best definition. The amount of reflection occurred or reflective surface. I don't know. Again, like I said earlier, these are just kind of off the top of my head definitions. You go out and find the full definition if you want to. But albedo is the fact that it reflects. For example, this paper has more albedo than this black tabletop. One's reflecting more light than the other, okay? Carbon sink is a material that absorbs carbon. Okay. An example of carbon sink is a tree. So example is a tree or forest. Those are carbon sinks, and there are some other carbon sinks, but those are the main one. So that's one of the problems with deforestation, cutting down all the trees in an area and the jungles, is because you're removing the carbon sink. Geoengineering, as we're not going to ask that, but that's basically a process of engineering and building carbon sinks and building things that try to help the environment, okay? Geothermal energy is using heat of the earth. And someone said earlier, it's not the earth's core, it's just earth, the heat from the pressure of the dirt at certain depths, but not from the core. We're not going to the core to get that. So using heat of the earth to boil water. And then we use that water to turn a turbine, to turn a generator, to produce electricity. So I think we're all good on that. All right, for the greenhouse gases, you guys should remember one of them. What's the main one? Carbon dioxide, CO2. Carbon dioxide. The second one that we spent some time on is methane, CH4. Some others are nitrogen dioxide, water, chlorofluorocarbons, CFCs, sulfur hexafluoride, but the two main ones that you'd be asked about are methane and carbon dioxide, okay? When we get an ice core, what information can we get from it? Well, we get the temperature and composition of the material, the temperature and the composition of material. So remember, we have that thin sliver of ice and it's got these little bubbles in it, right? We can actually go into that little bubble and test the composition of that, okay? So what did we find out from the composition? The composition and the temperature can be found from an ice core. What did we find out? Well, it's the same relationship. Temperature and carbon dioxide, or temperature and methane, is the same relationship. It doesn't matter which one. It's as the composition increased, so did temp. Okay? As the competition increased, so did the temperature. Fair enough. I think so. All right, let's get this, look on this back one. So you should remember that we talked about that not only do humans cause climate change or have an effect on this, but the earth itself is already going through some climate changes. And one of the problems or things to take into consideration are the Milankovitch cycles. And the three cycles are, you know, a larger orbit, okay, a larger orbit that can occur. Better or worse? The other pen's running out. So, for example, we have the sun here and Earth here, and we orbit like this. Sometime later, the Earth will be a greater distance away. All right, we also have a change in tilt. So the Earth has a tilt. Over time, that tilt will increase, decrease, change the amount of solar radiation that's coming in. And then finally, we got, that's what we're going to do with this light, I think. Bring it down here, maybe. This lighting is terrible today. We need something better. But anyway, tilt. The last one is the wobble. And so as the Earth is tilted, right, it creates a wobble, right? Are we good? How do you spell wobble? Bunch of B's and an L-E? All right, it has that wobble. And the point is, are there cycles that change the amount of solar radiation we get that are independent of us? Yes, and the Milankovitch cycles. We also got some up here with volcanic eruptions. What do volcanic eruptions do? They scatter the light, UV light, sorry, trying to write where y'all can see that, UV light. Sunspots are areas of greater radiation. So what's going to happen if we have a sunspot? We're going to have more radiation, the surface temperatures and all are going to be increased and be hotter. The Great Ocean Conveyor Belt is movement of warm water. Okay, And so the movement of that warm water obviously will affect the climates. And if the water temperature changes, then you don't have as warm water in certain areas and cooler water, and it affects the climate. And then finally, our El Nino, or the Southern Oscillation cycles. This is a cycle of cold and warm water in the ocean, and that affects the climates of those areas next to the ocean. Okay. All right, number 17, explain what's happening in carbon dioxide levels fluctuate up and down each year but have grown steadily. So you can see in this graph, 1960 somewhere there. Well, that's before 1960, but the Industrial Revolution started all this. We just kind of adding that there. The Industrial Revolution started all this when we built all these factories and built all these buildings here. You can see on this graph that it goes up and down, up and down, up and down, but yet at the same time, it's overall increased, okay? So things like the annual cycle up and down. What's causing that annual cycle of up and down temperatures? Just the movement of the earth, right? The rotation in the orbit of the earth. But overall, over time, it has increased. And so we just throw in there that some of this Industrial Revolution started some of this when we heavily produced that. You guys know the answer to these. I feel pretty confident. What's happening to the average surface temperature? There you go. Increasing. Rising. Increasing. What's happening to our sea ice? Decreasing. It's melting. What's happening to our ice sheets? Decreasing, melting. And you can go back and look in your notes and see the amount of sea ice we're losing and the amount of ice sheets we're losing. What about sea levels? They're increasing. Okay. The Arctic is warming faster than anywhere else on Earth due to the albedo. Explain why. So this is an interesting little phenomenon. We talked briefly about it. But, for example, ice has a high albedo. Okay, so ice has high albedo. Okay, so what? So reflects heat. So it doesn't hold a lot of heat. The ice reflects that and has a high albedo, doesn't reflect much heat. But the problem is when the ice melts, now you have water and it doesn't reflect as much. So the albedo is low, which means it holds heat. All right, and so if the water holds heat, that means that it's going to be able to melt other ice, which then has less albedo, which then holds more heat, and it's this little cycle that occurs, okay? So as the ice melts, you get less albedo, which means that it's going to melt even faster now, okay? So ice has a high albedo, a high reflective. It reflects the heat, doesn't hold it. As the ice melts and becomes water, the albedo goes down, which means it holds heat, which means it melts faster and faster. Okay. We'll pause right here for just a moment and make sure everyone is caught up.